Hi friends, in this video, we will learn more about the math module available in Python. Math module provides various mathematical functions and constants as defined by the C standard like pi, e, tau, fabs, gcd, ceil, floor, fmod, pow, sqrt, sine, cos, tan, and factorial. Let us go through each of these in detail. Mathematical constants are fixed real numbers which are useful in various mathematical computations. For example, the mathematical constant pi is used to calculate the area and circumference of a circle. The math module contains various frequently used mathematical constants that can be directly used in a program. Some of these constants are pi, e, and tau. Let us check out how you can access these constants in your code. First, import the math module. Now, executing math.py returns the value of pi, that is 3.141, up to available digits of precision. Similarly, math.e returns 2.718 up to available digits of precision. Math.tau returns the value of 2 into pi, that is 6.283 up to available digits of precision. Now, let us go through some of the functions available in the math module in detail, starting with the fabs function. The fabs function accepts a numerical argument and returns its absolute value or magnitude. For example, let us import the math module. Now, to get the absolute value of minus 3.24, let us execute math.fabs minus 3.24. It returns 3.24. Moving on to the next function. The gcd function returns the greatest common divisor of the provided two integer arguments. For example, let us import the math module. Now, execute math.gcd 54,24. The largest integer which divides both 54 and 24 is 6, which is returned by the function. Moving on to the next function. The ceil function returns the smallest integer greater than or equal to the numeric argument. For example, let us import the math module. Now, execute math.ceil 2.13. The smallest integer that is greater than or equal to 2.13 is 3, which is returned by the function. Moving on to the next function. The floor function returns the largest integer less than or equal to the numeric argument. For example, let us import the math module. Now, execute math.floor 2.13. The largest integer that is less than or equal to 2.13 is 2, which is returned by the function. Moving on to the next function. The fmod function accepts two numeric arguments x and y and returns the remainder when x is divided by y. Mathematically, it is equivalent to x minus n into y, which has the same sign as x and magnitude less than absolute value of y, where n is an integer. For example, let us import the math module. Now, execute math.fmod 2.14, 0.5. Now, the value of n, for which 2.14 minus n into 0.5 has the same sign as x and magnitude less than y, is 4. Thus, the result of 2.14 minus 2.0, that is 0.14, is returned. Let us take another example where we execute math.fmod minus 2.14, comma zero point 0.5. Now, the value of n for which minus 2.14 minus n into zero point 0.5 has the same sign as x and magnitude less than y is minus 4. Thus, the result of minus 2.14 plus 2.0, that is minus 0.14, is returned. Although this operation is similar to the mod operator, this function should be preferred when working with floating point numbers compared to x mod y that should be used for integers. Moving on to the next function. The pow function accepts two numeric arguments x and y and returns the result x raised to the power of y. For example, let us import the math module. Now execute math.pow 5, 2. 5 to the power of 2 is 25.0, which is returned by the function. Moving on to the next function. The sqrt function returns the square root of the numerical argument. For example, let us import the math module. Now math.sqrt25 returns 5.0 as the square root of 25 is 5. Moving on to the next set of functions. The trigonometric functions sine, cos and tan return the sine, cosine and tangent of a numeric argument, which is the angle given in radians. For example, let us import the math module. Now, executing math.cos math.pi divided by 3, that is 60 degrees, returns 0.5. Executing math.sine math.pi by 2, that is 90 degrees, returns 1.0. And executing math.tan math.pi by 4, that is 45 degrees, returns 0.999, that is approximately equal to 1. Moving on to the final function, the factorial function returns the factorial of a positive integer argument. If the value of argument is integer n, then factorial n is computed as the product of all positive integers less than or equal to n. For example, let us import the math module. Now, executing math.factorial 5 returns 5 into 4 into 3 into 2 into 1, that is the value 120.